A high-level agenda for what we're going to talk about today, over the next hour or so, 45 minutes or so, is we'll start with the landscape introductions, introduce sort of what we're seeing in the real world with enterprises. We'll do a comparison of legacy versus modern load balancers. We'll show in high level how Avi fits into VMware Cloud on AWS and how we can deploy in different use cases that we've actually seen and done at some of our customers. Some of these being multi-cloud deployments, hybrid deployments with workload migrations, VMC using for Horizon VDI use cases. And then we'll roll into a demo, and at the end we'll leave time for Q&A. The concept of multi-cloud or multi-cloud strategy has moved beyond just the initial idea or even like a buzzword, and it's become reality throughout most enterprises. As you know, a study done last year shows that 84% of enterprises have a strategy, and of these enterprises, they are running approximately 4 or 5 different clouds. And so running these multiple clouds provides unique challenges in themselves, but what this does is it also shifts, it causes a shift towards like cloud native applications and cloud native deployments, automation, and with support, DevOps support and CI/CD pipelines. This has also changed or matured expectations for how applications get delivered, where we are expecting applications to be delivered faster and at a lower cost. What Avi provides, Avi is an enterprise-grade load balancer, and here we show some of our the feature sets that we provide. So we have, as we say, we're an enterprise-grade load balancer. We provide application analytics and insights, so deep metrics and visibility into how your applications are performing, enterprise-grade load balancing feature sets, DNS IPAM management, WAF, GSOB global load balancing, and as well as container ingress services. We do this across multiple clouds, providing the same feature sets regardless if it's a public cloud like AWS or GCP or on-prem VMware or even VMware in the cloud. Being part of VMware, we've also, with our deep integrations with the feature sets, are able to deliver any app on any cloud with only a single platform. So let's take a step back, though, and we're going to talk about legacy versus modern solutions, legacy versus the modern load balancers, and how this has been sort of, how this has kind of complicated some transition to the public cloud. So the challenges we see with load balancers in public cloud, and this applies for VMC as well, is that these legacy appliances take too long to deploy, be it going through the procurement cycle as well as baseline deployments, baseline configurations, monitoring, getting everything set up as a brand new appliance. We see these appliances are expensive and they're usually deployed over provisioned, and we'll touch deeper on this topic in the next few slides. The load balancers themselves, for being in such a privileged point in the network, for being having such a vital point in application delivery, they're traditionally just been black boxes and very difficult to troubleshoot. Normal troubleshooting within the load balancers has traditionally been more reactive, and it generally needs to be done as an issue is occurring, and your primary method of troubleshooting is using TCP dump. I'm not saying this doesn't solve problems, or you can't solve problems that way. It's just very difficult and it's very time consuming. With the traditional load balancing deployments, we also see operational complexity. Scaling out traditional load balance deployments causes and increases this operational complexity, and we'll touch on that, this topic too as well in the next few slides. And then the last topic is the last challenge we see with traditional is it's not consistent across clouds, so not consistent across different deployment environments. So each deployment in a different environment is potentially a snowflake deployment. They're all unique, and there's no consistency, which then piggybacks off to the operational complexity. So out of these challenges, we're going to talk about or dig deeper into starting with over-provisioning and the capacity. When traditional load balancers are deployed, they're deployed in an HA active standby deployment. And so right off the bat, as active standby, we're only at the max capacity we could use would be 50% of the capacity you have. And as they're deployed, they're traditionally deployed or purchased with more capacity than you actually need. Why is this? It's because usually these are static deployments, which are hard to scale, hard to expand and scale beyond. And so you generally see expensive active standby appliances deployed when we're only using just a portion of the capacity. As environments, you run an environment like this for a while and everything was fine, and then eventually, just requirements come in. So you just have maybe new tenants, new environments get added, maybe new applications. They each want their own load balance appliances, and so we start adding additional pairs. And so we start seeing this process or this pattern repeat itself over and over and over multiple times. And so now instead of having two appliances, we're only using a little bit of capacity. Now we have numerous appliances where we're using minimal capacity, all repeating the same process. And so what happens when we actually start using resources on a load balancer? What happens when we get to a point where we're uncomfortable with the resource utilization and we've made a determination and we need to expand or scale out? What options are available to us? Well, with these legacy load balancers, we look at these, they're in and of themselves are islands of capacity. They are independent from one another. And so the options we have to scale out comes down to capacity management. We have to do the manual VIP placement. Well, sorry, I'm jumping ahead. When we want to expand beyond this, we have options of we can either purchase larger appliances. And by doing that, you would purchase, again, go through your procurement cycle, purchase additional appliances, migrate the configuration off the existing pair onto your brand new pair. During a maintenance window, do a cutover and hope everything works. You also have an option. The other option would be to, again, purchase another pair, baseline configure it, deploy it, get monitored, everything, and then do a manual decision process of determining which load balance applications you want to migrate off your existing pair and move them to another one. So essentially taking 50% of the capacity off of this pair and moving to another pair. Both of these processes are very labor intensive, time consuming, and costly as you purchase additional hardware. Going into operational complexity, as these pairs start growing, as you start adding more, now you've added more administrative touch points. There's also decision making that's required for when you want to configure a load balanced application. The admin needs to make a determination of which appliance is going to put that load balance application on. As we see, we have 16 pairs here. If I need to configure a load balance configuration, I need to determine which load balancer I have to put this on. There could be multiple determinations based off of available capacity. Is it in the right environment? Is it set up correctly? And then I have to log in, figure out which appliance that is, and apply the configuration. There's complexity to both manually, and you can just, if it's complex, it's done manually, it's even more complex to try to automate that. And all of this adds up to, it's not really designed to go into public clouds. Going back to the expectation slides, we already talked about the expectations of wanting to be able to deploy faster and be more flexible and agile. This is really counter to those expectations, and this really defeats this deployment model defeats that. So what about going like cloud native? Well, cloud native load balancers also have trade-offs. So as a legacy load balancer, you have the feature set, but you're trading off with the operational complexity, automation difficulties, and your lack of cloud native capabilities. What the native load balancers, native cloud load balancers have, they have that automation and elasticity. But what they lack in is the multi-cloud consistency, obviously, and then portability, as it's unique to just that cloud. So when we want to say, can I have the best of both worlds, this is where Avi comes into play. As mentioned on those initial slides, we provide, you're able to provide our full feature set, our enterprise-grade load balancing feature sets in the cloud with the automation as well as the elasticity. And this is what we'll start digging into in the next few slides, talking about how we actually provide that regardless of in the environment, whether it's on-prem or in a public cloud. The biggest differentiator for us versus a legacy load balancer is our architecture. And so we have a control plane architecture or a controller-based architecture where we have separated out the control plane from the data plane. And so we have our Avi controller, which is our control plane. And then we have at our data plane, these are our service engines. These service engines are the load balancers themselves. The service engines are where the virtual services exist, and that's where all the application load balance traffic goes through. That is your data path. The controller sits outside the data path. So the controller, from an application perspective, is passively off to the side. What the controller does is it's the single point of management. So an admin will never log into our service engines to deploy a load balance configuration. All of that admin all the admin tasks are done through the Avi controller. So the user will log into the controller. The user will create a load balanced application, a load balanced VIP, and then our controller makes a determination of which load balancer to put that on. In the previous example where I mentioned the user needs to determine out of my 16 pairs of load balancers, which load balancer can have this application, which one do I need to configure it on, that manual determination, our controller does that for you. So our controller has full visibility of the data plane. It has full visibility of the service engine capacity and how much performance or how much resources they're using at a current point in time. And so when an application gets created, having full visibility for all the load balancers, it makes a determination and it places the virtual service on one of those service engines. The service engines are a resource pool. So when you configure that load balanced application, if it gets put on one service engine, it is by no means stuck on that service engine. The controller can move, you have the ability to move applications or load balance VIPs from one service engine to another. And this is very, very beneficial when we go through some of the use cases within VMC. But we have that ability to move applications from one virtual service to another. The Avi controller, we talked about elasticity. Avi controller, since it controls the lifecycle of the service engines, the Avi controller, based off of demand, has the ability to dynamically create additional service engines. So going back to the example with a legacy load balancer, when you reach capacity, you have to deploy new, that manual process of deploying a brand new HA pair, active standby pair of load balancers, baselining them, getting them all set up within your monitoring tools, et cetera. This process, the Avi controller dynamically creates its own service engines. And again, all monitoring is done from the Avi controller, so there's no additional RBAC configurations, no additional monitoring. Everything's done through the Avi controller. The Avi controller also can delete service engines based off of this. If there's service engines that have been deployed or now they're no longer being used. This is helpful again for like public cloud where you're trying to control costs. You don't have, let's say, orphaned instances running, just using up CPU cycles and being idle. This elasticity is very important. It's beneficial for for our deployments. And we can do this across clouds. We can do this in multiple clouds. Since we are a software-based solution, we can have our service engines deployed on bare metal. Our service engines can be deployed as VMs within VMware. We can support container-based deployment, container-based environments, and we can be deployed in public clouds too. So we support Google, GCP, Azure, and AWS as well. A big advantage of being able to having separated the control plane from the data plane is that while the service engines are dedicated to processing application traffic, to serving up your applications, the controller can dedicate its time to performing control plane-based type activities. And one of these is analytics. So as we get into, and this will show us in demo as well, our controller has about 800 different unique data points that we can expose, from application performance all the way down to like the service engine components. So I like to say we have both, I'll say, infrastructure type analytics and metrics from like the service engines, packets per second, bandwidth seen on interfaces, all the way up to layer 7 type metrics for what's the average post size we see for an application, or how many 4x response codes is a application responding with. And so by the separation of our control plane data plane, our controller can dedicate itself to performing these activities and provide this rich data that's useful for troubleshooting and determining the health of an application. So no longer do you need to start doing is it required you to TCP up to perform troubleshoot applications. There's logs and there's metrics that actually are native within our controller, provided day one. As soon as you create an application, this data start collected that can be used to troubleshoot your application in your environments. And then also the controller does automation. Yes, we have a REST API. We integrate with VRA, VRO, Ansible, Terraforms. But when we say automation, we also mean to our controller automation. Our controller doing what we like to say is decision-based automation, where it can make that determination and call into the environment. So we integrate with the public clouds. We integrate with VMware, and that's where the controller can create service engines. And so in an instance, if a service engine goes away, be it software issue or infrastructure problems, and so the controller determines we're supposed to have 3 service engines. We've lost one. That controller will dynamically create another service engine to get back to where we're supposed to be at. It's that decision-based automation. The controller can also, if we lost a service engine, the controller will also knows which load balance applications were on that service engine, and then it'll configure and place them on the other 2 service engines. This goes back to that concept when I said the service engines is like a resource pool. That if the one service engine goes down, the applications get placed on the existing resources, so that your application is now back up to is now back available. There may have been some intermittent packet drops as it's being moved around as that loss was detected, but the controller does that dynamically. That happens on the fly. And so that's when we talk about automation, it's that decision-based automation that our controller does. And then scale. How can we scale Avi? And so we have 2 methods of scaling Avi. We can go horizontal or we can go vertical. When I say horizontal, it means we can deploy service engines. We can deploy more service engines. So we had that previous slide, we had 3. So if we want more capacity, we can have 4. We can have 5. We can go up to 32. We can go higher. I think we can do 200 plus. We can deploy multiple service engines to scale horizontally. If you wanted to go vertically, we could deploy service engines with more resources, more CPU, more memory. deploying a service engine is non-impactful. It doesn't, and it simply deploys another VM, if you will, and the VM connects back to the controller, and then at that point, it's instantly available for handling load balance traffic. There's no baseline configurations. There's no adding monitoring to it or authentication, because again, everything is done through our controller. And so that should be that's just a good primer for Avi, what we do and how we fit into the cloud use cases. And so going forward from here, now we're going to talk about VMware Cloud on AWS and how Avi fits into that. So VMware Cloud on AWS is a VMware SDC running on AWS bare metal. You have access to AWS's global footprint, so your SDCs can be deployed in any environment that AWS exists in, and you have direct access from your SDC to the native AWS services. VMC is it's a managed service that's operated and managed by VMware, so it's supported by VMware and its partners. And as we look at Avi and VMware Cloud, so again, Avi is it's a software solution, and we're deployed as VMs within VMC. So as you see in the diagram, so the diagram on the right has a high level showing of what SDC and VMC looks like. So you have your a management MGW area, and this is the resources that VMware supports. And then you have your CGW, which is your customer gateway, where your customer workloads, where all your app servers exist. And this is where you deploy Avi. So you can deploy our controllers and in CGW, and you can deploy our service engines there as well to be able to provide load balancing for applications within VMC. The solution is a 100% VMware solution, so it's single vendor support. You get full featured load balancing in GSLB, WAF, security analytics within VMC. The deployment options that we've seen and we've supported to deploy are like a single AZ, multi-AZ, a multi-SDDC, and hybrid migrations. And then customer use cases we see for VMC, we've seen for DR, expansion, capacity bursting, and EUC. When it comes to VMC, what's the benefit of Avi over whether native ELB or even the traditional load balancers? And the benefits that we have are provisioning time, our time to production, and time to production is for your applications. So you have fast provisioning with a scalable automated solution, easier troubleshooting, so you have end-user visibility, application analytics that helps you pinpoint where the issues are at. And again, it's a single vendor support, 100% VMware supported solution. It's a cheaper cost, so you both, as a software solution, there's savings on the product itself as well as OpEx costs. And then as a future roadmap item, today we're deployed as VMs, as you saw on the previous slide, VMs within the CGW. Next year we'll be integrated as a service offering within the VMware Cloud catalog to be able to deploy within VMC as well. So we'll have a full service integration coming up calendar year 2021. So use cases for VMC that customers use it for. You see it for data center extensions, disaster recovery, cloud migrations. So if you're like vacating one environment and going into another, common use cases are the common use cases I've seen this with our customers are evacuating on-prem data centers and moving into VMC on the cloud, and then just like app modernization. So this is high level for how we how Avi would look for a multi-cloud deployment. So the Avi controller, as I mentioned in the architecture slide, can deploy load balancers, can deploy our service engines into multiple clouds, and it can deploy in multiple clouds simultaneously. So in this example, I show our Avi controller managing resources or managing service engines in like an on-prem environment, as well as in a VMware Cloud and AWS. So with a single management point, you can control your global load balancing. This all can be done from a single point. This creates, you don't need to manage the service engines again. So when you deploy an application, you don't have to determine which service engine to place it on. You simply say, so in the sample, I'd have multiple clouds. I'd say, I'm creating an application. I'm deploying my application in VMC. And then the controller knows which service engines are in VMC, and it'll determine the best service engine to place that application on. Same goes for if I wanted to deploy it on-prem. I would configure my application, say I'm deploying this application in my on-prem environment. The controller knows the service engines that exist in the on-prem deployment and will determine the best placement for that application. And again, you have full access to your entire feature set with the real-time analytics and logs, all from a single point of management. So from that single controller, you have visibility into the application performance both on-prem and in your VMC environment. Workload migrations. This was a common use case that I was involved with some of our customers where they were vacating an on-prem environment and migrating resources into VMC. And so with this deployment, it looks like because logically it's a single environment, you have that layer 2 extension, our controller sees this as a single cloud. And so the controller has resources both in physical on-prem and in the VMware Cloud. And what we can do is when you want to cut them over, you have applications that reside in the on-prem. The controller can move those applications from that service engine and put them on the service engine in the VMware Cloud with just a few clicks of a button. And it happens in seconds. And I will show how that looks or how that works in our demo. I should do the demo. We actually had a customer that vacated their data center, and we moved the load balancing infrastructure from their on-prem into the VMware Cloud. We did it in a 1-hour conference call, where most of that was just verification and validation. But it happens extremely fast and it's very quickly. And that's the benefit of having that centralized controller with full visibility of your entire load balanced footprint. And then one of the really common use cases we had, especially with recent events in the past few months, was VDI and deploying Horizon in on VMC. So companies were scrambling to get up resources for telecommuting for their employees. And one of the use cases for that was to use VMC to deploy VDI and use Avi to provide that load balancing. One of the very first use cases when we were acquired by VMware was for that exact use case of VDI within VMC. Our internal VMware IT actually used Avi to deploy VDI solutions for new acquisitions. And you can see here's the feedback from them that instead of weeks, went to a day. So very easy to procure and provision these environments to get up and running. Okay. All right, with that, I will transition to a demo. Okay. So what I'm showing here is I have this is the UI for our controller. As I try to log in, I think I have my it's set idle too long. There we go. There's a little delay as I VPN across the globe to my demo. And so what you see here is this first dashboard I see is I have applications. I have 3 applications running. And this, as we mentioned, the controller can manage multiple environments. The first snapshot I get is just of applications. It's not giving, it gives us that holistic view of like, here's the applications I have globally running. I have my controller maintaining multiple environments. And so this controller has an on-prem VMware environment as well as VMC. So when I create applications, I put it into, I pick and choose the environment I want to run it in. I'm going to focus on VMC specifically. So as I go through the UI, I'm going to focus on that deployment. I'm going to go through our infrastructure. So service engines. I'm looking at the service engines I have, and as I go through clouds, I can see my on-prem VMware or VMC. I click on VMC. I have 3 service engines running in VMC. And so as I, just for the knowledge of that, I have 3 service engines. I have 3 load balancers that are running within my VMC environment. And so I'm going to go through the workflow for creating an application. I'm going to create an application. Say, give it a name. It's going to pick me. It's going to ask me which cloud am I going to deploy this in. I'm going to deploy this in VMC. Okay, VMC VS. Call it 2. I'm using IPAM within VMC, so I pick the network I want to place it on. The subnet it comes from. I'm going to make this HTTPS. I'm going to give it an RSA cert and an ECC cert. Which servers do I want to load balance? In my backend pool, there's 2 I'm going to use. I have these 2 servers, 10.128.32.2 and 10.128.32.3. I'm going to add those. And I'm going to click Save. And when I click Save, what the controller is going to do is it's going to look at the resources it has available within that cloud. So within the VMC cloud, I have 3 service engines. And it's going to make a determination on which service engine it's going to place this on. I am not telling the controller where to put it. It's making that determination on its own. So as the UI refreshes, it's going to bring me up the dashboard or the view of my virtual service. And I see it's already been placed. I have 100% or 100 for my health score. I'm going to hover over this. This is going to be a snapshot view of the virtual service. So it gave me an IP address of 10.128.12.1. It's on this service engine. It's 443 SSL. I can see its status is up. And there's some other configuration options we have. It shows me just a snapshot view of the configuration. I'm going to, so I just created this virtual service. I'm going to generate just a little bit of traffic. Off to the side, I'm just going to run some curl. You're not going to see it. I'm just going to curl the root. Just to generate some traffic so you can see the logs that come in right from the very beginning. And then let's do a test. Yeah. Okay. So this first is the analytics. This is the logs, and so these will start populating in a minute or so as it starts getting data and it averages it out. We start getting application logs immediately. So all the logs. And so this is default functionality. This comes with the product. This is from day one. This is what you get. And I made a couple connections. You see the connections come through. So here's my first one. And there's a lot of data for this connection. At the top of this connection, you see the latency for my request. So from the client, me to the load balancer was about 500 milliseconds. For the load balancer to the backend server was 3 milliseconds. For the after response was less than 1. The data transfer of 2 milliseconds for a total time of 521 milliseconds. So very, very quickly, if this was a troubleshooting session and I said my request is slow, you can immediately see why the request is slow. It's from the client to the load balancer. And the reason is I'm coming from corner VPN won't show, but I'm actually coming across the Atlantic to access this. But you can see the 4-tuple for the client-side connection. So I'm my IP address with the IP address of the source port to the virtual service on its port, and the back-end connection. So it's the server side. So the snatted IP on the service engine going to the back-end pool server. What was my request? Which service engine processed it? What certificate type was done in the TLS. I also did a 400 or 404 error here as well, and you can see the request for VMC demo. And so this application, I requested a 400 SAS code, or I requested a bad URI, I got a 400 SAS code. You can see where the request is coming from. All of these fields are searchable and filterable. So I could search, if I want to look for latency, you can look for, let's say greater than, the app response time is greater than 0. So you can do searches. I can search for, I can just say VMC demo, and it returns up the VMC demo request. So the troubleshooting aspect of this, it's no longer this, or you have an issue, okay, let's run TCP dump. It's, oh, you had an issue yesterday, okay, let me go back and look through some of these logs. I can actually see what was going on, what was happening. And so with this, you can also filter, you can also provide more information. So if I had, just do a couple more of these. It's not going to be very rich data because it's all from one source, but let me just refresh this. So I did a couple more requests. And so as I'm searching for VMC demo, I can say, what was the IP address is coming from? Oh, okay, this is the IP address that it's coming from. What service engines was this traffic going through? Okay, for all the 404s, the service engine was being processed by, okay, what server address is handling this? So 100% of my logs were going to this backend server. And so you can very quickly, if you're trying to troubleshoot, maybe misconfigured servers, you can do very quick filtering there. Going to the use case of, let's say we're doing that hybrid migration where we had applications running physically in an on-prem data center, and we wanted to migrate them across a layer 2 extension into our VMC deployment. How do we do that? So let's just imagine this virtual service, which is running on .10, is in the on-prem data center. You can go migrate. I'm going to migrate it. So migrate from this one, and I'm going to pick, say, I'm going to go to .9. Say .9 is in VMC. Migrate. So the controller then it's moving the configuration, puts the configuration on the VMC service engine, and then it starts bleeding traffic off of the old one, and as soon as it's done, it like flips the ARP, and so traffic will start being handled by the .9. And so if you were looking to migrate applications from like an on-prem or an on-prem data center into evacuated data center, and want to move them into your VMC, that's how easy it is to migrate applications across. And so now we see this one's running on .9. Again, it's going to be processing traffic. You can see it's accessible, so I added a couple new, close this. And so we'll start seeing, I did a /migrate, so the /migrate comes through. So traffic's still working, we're still receiving logs, all from that centralized controller. One other ability we have is we can actually have an application active across multiple service engines. And this isn't an active standby, so this is active setup. To do that, I can take my virtual service and say I want to scale out. And I'm going to scale it out onto, say, .17. And so what the controller then does is it places the application on 2 service engines. So it was already on .9. Now the application is running on .17. This adds not only capacity for an application, so now you have the CPU and memory resources of multiple service engines to process traffic for a single application. This also provides availability or resiliency for your application. So now, because we're running on 2 service engines, if we lose a single service engine, while the controller rectifies that scenario by putting the application on the service engine, you're still running on that original service engine, and so you just had momentarily reduced capacity until it gets placed on the service engine, but the application is always available. And so I'll start generating some more traffic. And so I did some additional requests. And so scale out. So I did this scale out, and you can see if I do service engines, you'll see the traffic is being processed or was handled by both service engines. And so that's how easy and quick it is to not only move your application from one service engine to another, but also to very, very quickly add capacity for a single application across multiple service engines. And I can also do the inverse of scale in, scale out. I can remove it from, say, 2 service engines, go back down to 1 if I don't need that extra capacity. And so this is where that troubleshooting that really comes into play. This is where all of those analytics and metrics come in that do that troubleshooting, the visibility as you go into a cloud with a common interface, a common experience across the different clouds. Let's make my metrics to come up. It takes starts with a 5-minute average for the metrics once the application gets created. So usually takes a little while for us to populate. But that demo should show you the power of that controller being able to control and manage service engines in multiple environments. Reiterating, saying that when I created my application, I didn't say put on the service engine. I simply said I'm deploying it into VMC, and the controller to determine which service engine to place that application on. And I had the flexibility at that point to, if I want to move it to another one, add more capacity for the application itself, just with clicks of the button. Okay. Let me go back to the slides. Let's back up. Okay.